Good morning. My name is Andrzej Czulak, and I am the leader of the Polish cluster of Composite Technologies. Today I would like to show why LCA is becoming one of the key tools for the composites industry. We usually choose composites because of their low weight, high strength, and durability. Increasingly, however, a customer, investor, or regulator asks an additional question: what is the product's real environmental footprint? The answer cannot be reduced to one emissions value per kilogram of material. We need to examine the whole life cycle, from raw materials through production and use to end-of-life treatment. In the next slides, I will show how LCA structures this analysis, where the most important composite hotspots appear, and why the practical guide prepared by Cluster can help companies move from questions to action. Composites have an environmental paradox. At the beginning of the life cycle, they may look worse because producing fibers, resins, and finished components can be energy intensive. But that is not the full picture. During use, lower weight may reduce fuel or energy consumption, while durability, corrosion resistance, and fewer repairs can create further environmental savings. At end of life, a difficult question appears: is recycling realistic, and what is the quality of the recovered material? This is why we cannot judge a composite only by its production stage or by 1 kilogram of material. LCA helps us test whether the initial environmental burden is genuinely repaid during the later stages of the product's life. LCA is not an arbitrary carbon calculator. ISO 14040 and ISO 14044 structure the analysis into 4 connected stages. First, we define the goal and scope, why we are carrying out the study, what function the product performs, and where the system boundaries lie. Next, we build the inventory by collecting specific data on materials, energy, transport, waste, and emissions. In the third stage, this data is converted into impact categories such as GWP, resource use, or acidification. The final stage is interpretation. We identify hotspots, test the sensitivity of the result to our assumptions, and draw conclusions for the product or process. The key principle is simple. Even very precise calculations cannot rescue an analysis built on a poor functional unit or unclear boundaries. For composites, the functional unit is especially important. Comparing 1 kilogram of CFRP with 1 kilogram of steel can be misleading because those quantities may not perform the same task. The fair question is how much material is needed to provide the same load capacity, stiffness, durability, and service life. In the example presented in the book, 1 kilogram of CFRP may replace 3 to 4 kilograms of steel while providing the same function. Only after defining the comparison this way can we assess the real hotspots: fibers, resins, and additives, process energy, waste, and end of life. The functional unit and system boundaries are therefore the foundation of a result that can be defended in front of a customer, auditor, or EPD verifier. This example shows how the full life cycle can change the conclusion. In the car door comparison, the CFRP option has a production footprint about 80 kilograms of carbon dioxide, equivalent higher than the aluminium option. It is also 10 kilograms lighter, so it saves fuel during vehicle use. Under the assumptions used in the example, the additional production footprint is repaid after about 87,000 kilometers. Beyond that point, the CFRP option begins to achieve a lower total GWP. It is important to stress that 87,000 kilometers is not a universal figure. The threshold depends on the use profile, mass, fuel consumption, durability, repairs, and end of life. This is precisely why LCA should be used to test scenarios rather than to confirm a conclusion chosen in advance. A well-prepared LCA works in 3 areas of the company at the same time. For designers and R&D teams, it identifies hotspots and allows materials, processes, and end-of-life scenarios to be compared. For sales teams, it provides comparable data for customer discussions, tenders, and supply chain requests. For compliance teams, it becomes the foundation for EPDs, digital product passport data, and credible communication with a lower risk of greenwashing. Importantly, a company does not need to begin with every product and every life cycle stage. The book proposes a starter pathway. Choose one representative product, use an A1 to A3 scope, and collect BOM, energy, waste, and transport data. A first useful model can be developed in 4 to 6 weeks. European project ResC4EU extends the LCA perspective into broader supply chain resilience. The EU-funded 2024 to 2026 project brings together 10 partners from 7 countries and aims to reach more than 1,000 SMEs across 14 industrial ecosystems. Its supply chain resilience platform connects manufacturing companies, suppliers, logistics providers, and technology innovators. The 4 public demonstrator themes show the bridge between sustainability and resilience, energy savings, resource and materials savings, climate neutrality, and supply chain resilience. The platform also presents services such as resilience self-assessment, crisis supplier identification, global warming potential calculation, risk and disruption alerts, matchmaking, and AI-tailored strategies. For a composites company, this means LCA data does not live in isolation. It becomes part of decisions about suppliers, transport, operational risk, and decarbonization. The project and platform links are shown on the slide. If we want to move from general knowledge to a first practical LCA, this book can significantly shorten the journey. Its 15 chapters cover the method, standards, market requirements, and European Union regulation. It includes ready-to-use templates, checklists, exercises, and case studies on CFRP, GFRP, biocomposites, construction, and wind turbine blades. The authors also described 3 levels of development: starter, EPD ready, and DPP ready. This makes the publication useful not only for LCA specialists, but also for process engineers, designers, sales teams, and managers. I encourage you to treat it not as a document to read once, but as a working toolbox for your own products. Information about ordering or availability is available directly from the publisher using the contact details shown on the slide.